Hi, good morning. I hope you are doing good.
चलो भाई देखो अब मैं क्या करता हूँ.
Yesterday in the video I told you that I won't show my face, but I was bluffing. Sorry about that. And behind me is the famous cactus garden at Stanford. And this garden is called Arizona Garden. I can show you around a little bit. You can Google it. I don't know about the history. Coming to the video, that today I'll be talking about flexible docking in ADFR, how you can use AGFR-GUI to do the flexible docking. Yesterday I was talking about the rigid docking, and today I will be talking about the flexible docking. One request to you all, this is my new channel, Omixium, or whatever it is. Please subscribe to my channel. Thank you very much. I'll show you around. Coming back to the video, we'll be doing the flexible docking. So we visit the website of AutoDockFR and we go to the documentation where the flexible docking documentation is there. But we are going to generate the target file using the AGFR-GUI. I have two files, which is the receptor and the ligand PDB-QT file. So you type in AGFR-GUI, it will pop up the window, and then you load your receptor PDB-QT file and your ligand PDB-QT file all together. Okay. And then you have these four options. Yesterday I mentioned about the four options where you can define your grid box, the whole protein if you are doing a blind docking, and you can concentrate on the ligand, which is this button, and you can define a grid box accordingly. And then you can choose residues. What are the residues for the defining binding site? And there is a fourth option. Yesterday I forgot to mention that you can also define the grid coordinates with the box size, etc., like you do in NGL tools. Okay. And for the flexible docking, you click this button, which is called flexible residues, and it will show only the residues which is defined inside that grid box. What are the residues? So you choose accordingly what are the residues that you require for the flexibility, and then use it for AutoSite algorithm to define the grid box. It's like the same functionality as AutoGrid, but ADFR or AGFR-GUI has this functionality called AutoSite, which can define the grid coordinates, the grid box, etc. And you choose the maximum surface area for your calculations, and then you define you want to generate the coordinates for all the atoms, and then you click generate. So it will create a TRG file, which you can see I named it as pocket.trg, and you can check about the contents about the TRG file using about pocket.trg. So it will tell you all the parameters that you define to to generate the grid box, and also it will define this flex rec where you define all the residues that are used for flexible docking. These are your flexible points actually. You can extract the file as well, and you can see that there is a file called flexrec.pdbqt where your flexible residues coordinates are mentioned and all the map files required. The command to perform the docking is the same command, because ADFR recognizes the flexible residues automatically, and you can read about the parameters that are used for these docking algorithms. Okay, so you paste the command, and then you define your TRG file, which is pocket.trg. That's your grid coordinates, and then you define your ligand file as ligand.pdbqt. It will automatically detect the flexible residues inside that TRG file or TRG directory, and then it will perform the docking against the flexible residues. And that's it, and you press enter. I'm using the default values, so you can change it later on. It will take, since your grid box is so small, it will take less time. And as you can see, your docking results are ready with binding affinity scores and your RMSTs, etc. Then you can open this DLG file where all the information that was printed on the terminal will be printed over here as a file, and you can analyze the results as well. Then you can open the pdbqt.out file in Chimera X, and you can load your receptor file as well to see what are the flexible residues that has been pointed out during your grid file generation. And you can see that I have defined 3 flexible residues, which are methionine 286, ASN 265, and leucine 231. You can see that there are multiple residues coordinates over here. Those are the aggregated file of those coordinates that are being flexible during the docking, and you can see your ligand is docked right into the pocket with the flexible residues. That's it. I mean, this is how you do flexible docking, and most widely used algorithm to redefine your docking algorithm apart from the rigid docking. Rigid docking is mostly used for the virtual screening, but flexible docking is the actual docking that if you want to compare it with the X-ray crystallography structures, and then you can define your flexible residues to identify what are the binding poses. And yeah, that's it. Thank you very much.